Hey, Algebra 1 here with your cool down help for Lesson 2 in Unit 3. And we're looking at these relative frequency tables. And we have to create one from a two-way table that was given to us about these 80 students that were asked to write a sentence and record the hand that they used to write with. So a teacher determines whether each sentence is written neatly or not. And then the results are summarized by the table. So we had 5 people that wrote left-handed and it was neat. 10 that wrote left-handed and was messy, 34 that wrote right-handed and was neat, and 31 that was right-handed and messy. And so what I went ahead and did here is I did some totals for how many people are left-handed and how many people are right-handed, and you can see that there's 80 when you add those together all together. So that makes sense. But the reason I went along the rows here was because of what number 1 asked you to do, which was complete the relative frequency table with the correct proportions so that it could be used to answer the question. And this is the important part, among left-handed writers. So this population is a row set, right? Left-handed are on the rows, right-handed are on the rows, neat and messy are columns. So whenever they said among the lefties, I was immediately thinking, okay, I need to talk about the 15 people in that row that are left-handed. So I need to make a relative frequency table by row and not by column. So that's why I have these totals in here. Everything that I set up in this frequency table is going to be based off of out of 15 and out of 65. So for the first part here, left-handed people that write neat, there's 5 of them out of 15 left-handed people. So making it relative to the row is going to give me a setup of 5 out of 15, which when converted, that's a third. And that's equal to about 33% when rounded to the nearest whole percent. And then I don't even have to do this other one with the setup because 10 out of 15 would be the other 67% that would add to the 33 and make 100%, right? But that would have been found by doing 10 divided by 15, which is 66 and 6/10 repeating. All right. And then the right-handed, we can do the same thing. This one sets up as 34, but now we're relative to its rows total, which is 65, not 15. 15 wouldn't make sense because there's more than 15 people that are right-handed writing neatly. So this one's out of 65 because it's relative to its rows total. And so 34 out of 65, we can go to our Desmos calculator and calculate its percentage just by setting up the fraction and converting it to a decimal and then moving the decimal over 2 places. So that's what I'm going to do if Desmos decides that it actually wants to work. If it doesn't want to decide that it works, there it goes. Okay, so 34 divided by 68 is, that wasn't the numbers. Let me go back. Sorry about that. The numbers were 34 and 65. 68, they've been really easy. They've been 50%. I'm expecting it to be around 50. I just wanted to make sure I get the right number. So it was 34 out of 65, which is 52%. So that one is 34 out of 65, which is 52%, which by adding up to 100 would make this one 48%. All right, so we got our relative frequency table based upon the rows of left-handed versus right-handed. And now we can answer the question. Use the table to determine the percentage of right-handed writers who the teacher determined have messy handwriting. And that would be the 48%. All right, and there you go, guys. That's relative frequency tables. It's not that bad as long as you know how to find a percentage and you can kind of go through the wording that specifies whether you're in a row or a column. Other than that, it's just setting up a number out of a total and converting it to a percentage. Later.